What's up everyone, welcome to our 9th Python tutorial, and today we're going to be doing something a little bit different, but it is hopefully really exciting for you guys and really fun. So by now we've covered the second section in Python, and we've gone over everything that has to do with flow control, such as if then else statements, while loops, and for loops. So today we're going to be doing something that I've grown to love and enjoy doing all the time now, and that's building algorithm applications, and especially we're going to be utilizing while loops. So what exactly is an algorithm? So an algorithm is a process or set of rules to be followed in calculations or other problem solving operations, especially by a computer. So we're going to be using algorithms all the time, and we use algorithms throughout our daily lives, and I have a quick example of an algorithm right here. Right, and this is just a simple grader for our letter grades, and right, if you score over a 90 or equal to a 90, that's an A, and then greater than or equal to an 80, that's a B, greater than or equal to a 70, that's a C, and then less than that, it's going to be a D. So you can see the simple flow control that occurs with this algorithm, right? So we're simply going through and understanding each step and acting due to the conditions. So right here, you can also see that mathematics and computer science are deeply connected and intertwined, and it's essential for us to understand the connection and utilize them in our programs. So that's where we're going to be focusing a little bit more on today, and we're going to cover the topics of Fibonacci series, multiplication, and star designs. So nothing really new in the Python world, but we are going to learn how to implement some of the stuff that we've learned over these past couple of tutorials. So for the first program, I do encourage you guys to pause and try this out. But just to start out, what you're going to be doing is you're going to be creating a Fibonacci series program. And simply what it should do is it should print out a set of numbers that all follow the Fibonacci series. So I recommend to you guys to take some time, pause it, and go ahead and try to build a Fibonacci series program. And you can see the application and where Fibonacci series exist in our real world. So go ahead, pause it, and I'll be waiting for you guys back here. Okay, thanks. Okay, so by now, I'm sure you guys have cracked out how to do the Fibonacci series program in Python. But if you haven't, I'm still here and I'm going to be making it for you guys. So first we need to understand what exactly is the Fibonacci series. And simply what it does is when we add two numbers, let's say we have 1 or 0 and 1, because that's how it starts. We have 0 and 1 with our A and B. And whatever we get as the result, and that's going to be 1, we simply add that back with our second number. So you have 0, 1, and then 1, 1 become 2. So 1, 2, add to 3, 3 and 2 to 5, and 5 and 2, 3 and 2 to 5, and then 5 and 3 to 8. And Fibonacci series is obviously, like other series, have the potential to go on forever. And once again, they represent structures and sequences that model our real world. And one example that is often found is flower petals, and they follow Fibonacci series. So let's go ahead and write this program. Okay. Alrighty, so we have finished this program for our Fibonacci series. And let me go ahead and walk you through what each aspect of our program is doing. So currently we have 4 variables to start out, all integers, and we have num1 and num2, which represent our A and B, and we have an interim value, which you'll see the importance of pretty soon, but our interim value is equal to the value of num2, which is our B. And then we have a counter, and everybody knows what a counter does, right? Just keeps track of time, or iterations in this case. So right now, we're simply saying print out Fibonacci series value number 1, because that's our A value, just to start out. And then we're getting into the crux of our program, right? This is the while loop, and we're keeping track using a while loop, and we're utilizing this while loop because we don't know how many iterations they're going to be within 100. So that's why we're going ahead and using the while loop, because the number of iterations is not known. And right here you have print Fibonacci series, and it's going to print the numbers, which number it is within our series, and then our result. So once you see what it's doing right here, you can see that it's going to go ahead and print out number 2. So we have A and B so far that we've printed, and then we have our interim value. So once again, we're setting it to B, and we're saying num2 is equal to num1 plus num2. So ultimately what we're saying is we're assigning B the value of the sum of A and B. So we're basically doing what we're doing right here, where we're saying C is equal to A plus B. And once we do that, then we're setting our num1 value to our interim value. So what it's going to be doing right here is it's going to be switching what values it has. So we have our A plus B, which gives us a C. Once we have our C, our B value is going to be equal to C, and our A value is going to be equal to B. So it's going to be systematically moving across so that it can add in the Fibonacci series. So it's a little confusing to wrap your head around, so it's important to understand how I'm doing this. And there are a multitude of ways to do this, but this is just one way that I've worked out how to do. So let me go ahead and print this out. Right, and you can go ahead and see value 1, 0, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and so on and so forth. So it's running up until our last value is less than 100. So we can set this to any counter number we'd like, but that's just a quick set of Fibonacci series numbers. And once again, I hope you guys understand how exactly I'm doing this portion of our program. Next, let's go ahead and do the second thing on our list. Let's go ahead and try to make a multiplication table. So we're going to be once again utilizing a little bit more of our while loops. And this one's a little bit more complex, but once again, I do encourage you guys to go ahead and pause me and take some time. You know, it doesn't matter how long you take, it's as long as the job is done. Just take some time and try to complete this program on your own. And simply what you should do is you should be making a multiplication table. That's it. And you can utilize while loops, for loops, whatever simply helps you. I've got a specific way of doing it, which I'll show you guys once you come back. So once again, go ahead and pause, and I'll be here waiting for you. Okay, so once again, I'm sure you guys have cracked it, but just in case, I am here to save the day. So let me go ahead and get started. So here I've completed our making multiplication tables project, and right, you can see we have two variables, and what this first variable is going to be doing is it's going to be dictating the number of multiplication tables that we're going to be having, and this second one simply counts to which number we're going to be going until. Right, so this first line, it's fairly simple, and all we're doing is we're setting a boundary for our table, and it's just a design aspect. It's just going to make this dotted line that's just going to set our little table up. And next we have our first while loop, and simply what we're saying is we have the number of multiplications tables and we're setting it less than 11. So that means we are going to be creating 10 multiplication tables within this. And within, we're setting our counter multiples back to 1. And that's because whenever it is iterating through and it comes back to our while loop for the next loop, it's going to have to reset counter multiples to 1 so that it starts at the right point for our table. And next you have another while loop, and it's our counter multiples, and we're saying it's less than or equal to 10. And once again, this is a nested while loop. And simply, the main part of what we're doing occurs in this line right here. And simply what we're doing is we're using this to space out what we're doing over every 4 spaces. And inside we have num m tables times counter multiple. So we have in the first case it would be 1, and when it comes down to here it's going to be 1 times 1 is 1, and it's going to print that out, and the counter is going to iterate through. So it's going to be 1 times 1 1, 1 times 2 is 2, and so on and so forth. And once it reaches 10, it's going to exit out of here and print out a line to make a space, and then it's going to iterate the num tables so that it can go on to the next one. So now you're going to get into the 2 times table, and you're going to go down, and eventually you're going to iterate through all 10 times. So ultimately this while loop is going to be running 100 times, and this outside while loop is going to be running 10 times. And lastly, it just ends with our design once again. So let me go ahead and run this program, and you guys will see it's a fairly simple program that looks a little complicated on the inside, but it's truly nice to look at, and it makes this pretty neat program. So you can see right here, I can go ahead and alter some of our features. Let's say I want to make it so that it doesn't run 10 times. Let's say I want 5 tables, or let's say I'll make it a weird number. So I make it 7 tables, and they all go up to 3. So now we're just going to get 7 times 1, 7 times 2, 1 times 1, 1 times 2, 1 times 3, all the way to 7. So right here you see, or 6, my bad. But yeah, we have 1 2 3, 2 4 6, 3 6 9, 4 8 12, 5 10 5, and 6 12 16. So there you see we're making tiny multiplication tables, and you can see the power that while loops have and how exactly we can use that algorithmic standpoint to make our application. So lastly, I'm going to end with 2 challenge designs, and these are pretty simple challenge designs, and they're rooted around the same basic concepts. So I'll go ahead and challenge you guys to make a program where it simply designs some receding stars. So you'll start out with a large number at the top and slowly come down to 0 using a while loop. So hopefully you don't end up printing a bunch of lines where you have like 10 stars, then 9 stars, and then 8 stars. I really want you guys to learn how to use a while loop and how we can use it to make some of these algorithmic applications. So I'll go ahead and walk through how to make this receding stars. But before I start, I want you guys to once again pause and try to do both these challenge designs, and I'll start to quickly make both of them. So pause me, and then yeah, I'll be here to make the program. Okie dokie, so I have completed both of our challenge designs, and let me just go ahead and walk through each of these quickly. They're pretty simple. So right here we have some user input, and we're saving our input, and we're creating a variable, and we're going to call it star print. So this is our variable star print, and what it's going to be doing is that's what is going to ultimately be printed out in each iteration of our while loop. Right, so we have our while, and we're saying while stored input. Right, so the number of rows we've while is greater than 0, in this case in our receding stars, we are going to print out star print into our stored input. Make sure that says input. And once it's going to continuously print out. So let's say I said 5 rows. It's going to print out 5 stars, right, print them out right here. And then it's going to subtract that from my stored input total. So it's going to, from 5, it's going to become 4, and I'm going to print 4. Then 3, then 2, then 1. So you can see it's a fairly simple program. So let's enter the number of rows. Let's say I want 7 rows, and you can see right here in the first row there's 7 stars, then 6, then 5, then 4, then 3, then 2, then 1. So there you can see the more like design oriented aspect of Python, and you can utilize this sort of printing features and ultimately make some pretty cool designs. I've seen some videos where they utilize while loops and for loops in order to make some pretty intricate drawings using these star patterns. So you could go ahead and try that out later after this program. I will link some videos into which people have done some of these designs that I mentioned. so you can go ahead and check those out after watching. And for this next one, this is our increasing stars design. And right, same thing, you're inputting your number of rows, you're storing the input, and this time we have a counter instead, because we're going to be counting up as opposed to subtracting down. So once again, you have our star print, you have our while loop, and you're saying while our counter is less than or equal to whatever row we stored input, we're going to once again assign our star print variable to this, and instead we're going to be multiplying it by the counter. So let's say we have 10 rows, right? It's going to start out with 1, and it's first going to do star print star into 1. So it's going to have 1 star printing right here, and then our counter is going to increase by 1, and then the next time it will have 2 and 3 and 4 and so on. So these were a couple of interesting programs, and these, so all these programs were pretty interesting, and I hope you guys had some fun and it challenged you a little when learning how to make these algorithmic applications. And there are tons of these kinds of applications online, and I recommend you guys check those out. Once again, I'll link my program in the video, as well as some other videos that I've utilized in order to make some of the programs you guys have worked through today. So I hope you had fun and make it an awesome day, I guess. Thank you. Bye.